All right, hello, this is Mr. Frazier, and we're going to go over 11.3 and 11.4, the assignment as well as the notes. Now, I will tell you that a lot of this stuff is not in the book, or it is in the book and it's all spread out. So, we're going to go over a few things so that you understand what this means, because a lot of this is vocab based. The first one is finding the zeros. Okay, when you find zeros, finding zeros is the same as x-intercepts. Okay, finding the zeros means finding the x-intercepts. It also means finding the y-intercept. Now, why do I only use one y-intercept? Well, x-intercepts because your parabola is either going to go through the x-axis twice, it's going to go through the x-axis once, or it will not go through the x-axis at all. But it will always have a y-intercept. Okay? And we've talked about the y-intercept. You plug a 0 in for x, correct? And we know the x-intercept is when you plug a 0 in for y. All right, now, understanding what the zeros mean. The zeros are your x and y intercepts, and plugging in numbers to find one or the other. All right, and we talked about maximums and minimums, being that maximums are halfway in between. This is called a line of symmetry. Now, we'll talk more about that line of symmetry later, but understanding that the maximum or minimum is halfway through where your x's meet. So that means this is half and this is half. So let's say this was -4 and this was 6. That means the distance between these two is 10. That means this would have to be at an x of 1. Why? Because 1 is 5 away from 6, and 1 is 5 away from -4. It's in the middle. All right? Okay. So understanding where you find these values, what you're looking for when you're finding these problems. Okay? You also need to be able to tell me what the domain and the range is. And we've talked about domain. Domain is all of your x's, and range is all of your y's. And we said when we have a parabola, our answer for the x's is always infinity, right? Unless it's a real life problem. Then we can't have negatives. So if it's a real life problem, then our domain is from 0 forward. But if it is just a parabola and they say, what is the domain? The domain is always all real numbers because our parabola keeps going outwards forever. Okay, and we talked about this in class. I had you hold your arms up to show me how a parabola looks. The range is the one that changes. Your range is all of your y answers. And that's based on your maximum and minimum. So for example, this problem right here, all of the y's that are for this parabola are less than 0. In this problem, all the y's would be this way. Whatever this number was here for y, all of my y's would be lower than that because the parabola is opening down. If the parabola was opening up, all of my y's would be greater than that number. Okay, so understanding what direction the parabola is going at and what the value of my y's are tells me what my range is. So let's look at a sample problem. I'm going to cover up with a card the answer so that you can see what we're talking about. So if I wanted to know what the domain was of this problem, the domain is all real numbers. It's a parabola. But the range is every y value less than 2. Because it opens down, all of the y values we could have are going to be smaller than 2. Now let's think about this. If I go this direction, is any of the parabola going up? No. So all of the y values have to be less than this value of 2. This one, the parabola is going up. All the y values got to be greater than a half. And the reason I know it's a half is because 1 is 2 away, so that means this is 1/2. So it's probably more like a quarter. So everything's got to be bigger than a quarter, which would be 0.25. All my y values are bigger. My x's are still all real numbers, or infinite, because it's going to keep going up and away from each other. All right, so that is the big piece of information of understanding what happens in 11.3. Now we're going to look at 11.4. Okay, so those vocab words and understanding what you're doing. 11.4 is where they introduce something about getting your facts straight. This is about factoring. And it's the introduction to factoring. So you've been writing out in factored form on the Carnegie software, as well as in class, when you multiply two binomials. So we've had stuff like this, and we've had that's what the Carnegie software can let you do. And when we've been talking about this, we've been multiplying it out using the distribution property, and we get an answer. That answer is what we call quadratic form. Okay, that means we have negative 2x squared plus 240x plus 9,000. All right, now how did I do that? Again, that's my smiley face. This would be 300x. This is negative 60x. That's where I got the 240. The nose, that's 3 times 3 is 9 and 3 zeros. Okay, and then the smile, that's negative 2x squared. All right, so understanding that this is called factored form, this is called standard form. They are the same. This one's just multiplied out. Excuse me, this one is multiplied out. This is before I multiplied. Going forwards, going backwards, forwards, backwards, forwards, backwards. Okay, so understanding which one's which. This is factored form. This is general form or standard. All right, why is this important? Well, now we're going to be doing dividing. We're going to be taking some problems and working backwards. We'll start with something really, really easy. And 42. And you're looking for the biggest number that goes into 12 and 42. Hopefully you know that number is 6. This is where having a calculator or the mental math skills is going to catch up to some of you. So I divide 12 by 6, I get 2x. I divide 42 by 6, I get 7. And notice, this is the factored form of this. I have worked backwards. I have undone the multiplication. And if I were to turn around and factor it or distribute it, I should get this answer. Okay, so going forwards and going backwards. Forwards, backwards. Forwards, backwards. All right, so why is this important? Because our terms tell us things that are happening. Believe it or not, this is one of my zeros. When I'm in factored form, that will always be one of my zeros. Some of you are like, well, wait a minute, what do you mean it's one of my zeros? That means when I take 2x plus 7, I would put it equal to 0 because my y is 0. Remember, I'm finding the x-intercept. So I put a 0 in for the y. And my x-intercept would be negative 7/2. Doesn't go in evenly, so we just keep it as a fraction. But why? Because it doesn't go in evenly. This is my 0. This is where my parabola would touch the x-axis. Now, the problem is this is not an x-axis because there's no 2 of x-axis, because this is not a quadratic. If I had started with this, Now it's a quadratic function. When I factor the quadratic function, I still do the numbers first. So I would take out the 6. So I'm going to rewrite this problem so that you understand. That's my first problem. My second problem, I'm going to make a quadratic. And I have to look at it. Can I take a number out? So yes, I take a number out. My second question to myself is, can I take a letter out? Can I work a letter out of this? And your answer is yes. As long as both terms have a letter, I can take the smallest amount, which would be 1 out. So I pull the x out. Now I have 2 terms. I have 2 zeros. I would have 6x equals 0 and 2x plus 7 equals 0. Notice what makes this problem and this problem different. This has x squared. This does not have x squared. That means this is a line. It's only going through the x-axis once. This has an x squared. That means it's going through the x-axis possibly twice. So I do my 0 work. I got to factor first. Then I turn around and put them equal to 0. The outside's equal to 0. The inside's equal to 0. And then solve. Now, looking at my factored form, I can tell a lot about it. Remember we did the ax squared plus bx plus c. This first term tells me whether the parabola is going up or down. Correct? Excellent. So when we have factored form, and we have it written in factored form here, this leading coefficient still tells me the same thing. If this is negative, it's still telling me the parabola is going down. If it's positive, it's telling me the parabola is going up. And these are my zeros, meaning I take this problem, put it equal to 0, this problem, put it equal to 0, and that's where my x-intercepts are. All right, so you have to be able to read that. So I'll give you an example problem. So I'm looking at this sample problem here. Can you tell me which way the parabola goes? Hopefully you're telling me it goes down because this is negative. Where are the x-intercepts? Well, we have x minus 4 equals 0 because that's one of the zeros, and x plus 1 equals 0 because that's one of the zeros, and then I solve. This one, x equals 4. This one, x equals negative 1. Where it crosses the x-axis would be negative 1 and 4. That's what these 2 points would be. Now, most of you are looking at this and go, oh, wait, from here to here is 5 away. Like this goes to 0, and then 1, 2, 3, 4. So that means the vertex would be at not 2.5, even though they're 5 away from each other. 2.5 is the distance. So some 4, 2.5 would be another 2.5. Now that's just a little weird, but you'll get over it. That would be your x for your vertex. All right, so again, factored form, finding the zeros. 0 in for y, you get an answer for x. Remember, that means these points are 4, 0 and negative 1, 0. Ordered pair. And that is the factored form of that problem. All right, now, some of you are going to go, Mr. Frazier, how do you get that factored form? Well, we're going to go into a process in which you do factor polynomials where they're harder. And we're going to go through how to read it carefully. And if you read it backwards, you'll be able to do it. Right now, they're expecting you to do it with a graphing calculator. So you find your x-intercepts and then be able to write it in factored form. So if I give you the x-intercepts, you should be able to go backwards. Notice, in this problem, it says x minus 4, yet the x-intercept is positive. In this one, it says x plus 1, where here the x-intercept is negative. Yes, that will happen. Okay, so you can keep going on that pattern. Now, finding the zeros, finding the x-intercepts. Right now, I will give you the factored form. You won't have to factor it. Now, if it's something really basic like this problem, you should be able to do it. When they get more complex, then I will show you how to do it. Okay, and that's a little bit later on. All right, so being able to find zeros, understanding what's happening, the vertex, and then we're going to talk about the axis of symmetry. That's in 11.5. So my next video will deal with axis of symmetry of a parabola and the vertex. That vertex being the maximum or minimum point. That's this point where it turns around. Okay. Now in the software, you've been moving it with the slider, and the slider moves over and it tells you what the vertex is because you're looking for the highest y value. But we're going to go through that later. Okay, so understanding quadratics and factored form, and then we'll talk about how we go from one form to the other. Okay, how to factor and how to multiply it out. For right now, you should be able to go from factored form to standard form. You should be able to multiply it out like I did here. That's what they're expecting you to be able to do. We'll talk about the other form when we move on to the next chapters. All right? Okay. So the next video you'll see we'll have to deal with the assignment work. Okay. And we're going to use the sample assignment that they do. We're looking at problem 2. The profit of masking tape company, and here they give it to you. And based on this information, when you look at this, what is the x-intercepts? Well, you should see that they're counting by hundreds. So this would be 100, 200, 300, 400. So they're counting by hundreds there. And then this would be 500, 600, 700, 800, okay? So what would be the x-intercepts? So I'm looking at it, and I'm like, okay, I know what the x-intercepts are. I can see that. The question they asked me originally is, what is the domain of this function, and what is the domain of the problem in this situation? Okay, well, the domain in this function are all real numbers. Okay, that means all real numbers would be our x's because it continuously goes down and out. In this problem, I don't make a profit until what? I don't make a profit until I sell. Correct. Hopefully you counted 200 masking tapes. Notice, 200, I'm making profit, 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 no more profit. Okay? This is the profit I'm making. I start making a profit after I've sold 200, and I stop making a profit when I sell 800. So in this problem, the domain for making a profit would be from making 200 rolls of duct tape to 800 rolls of duct tape. Now, if I don't sell that many rolls of duct tape, I'm going to take a loss. for making that kind of duct tape. All right, so let's move on. We'll look at the second part of this, and it asks, what is the range? Okay, the range is all the y answers. So now I go back here, and all my y answers are less than what number? Well, let's see. If I go across the top here, all of my y's, are they greater than or less than? So which way is my parabola going? Hopefully you know it's less than 10,000. So all of my ranges are less than 10,000. Does it increase? Does it decrease? Yes, it increases and then decreases. And then it's asked, when they want a profit of 1590, so now I look on my chart, 1590, I need a profit of 1590. Am I going to get to a profit of 1590? Well, 1590, is that 1500 or 15,000? 1500. 1590. So we're going to look at the chart. 1590 would be down here. So I make a profit at 1590 of approximately $250. Now I'm estimating. Okay. Notice it's not going to give me a solid number. All right. I'm not worried about the interval of increase or the interval of decrease. We just did the profit. X-intercepts of the function and the y-intercepts. You know the x-intercept is going to be 80, 800, and 200. Okay. The y-intercept is going to be what? Right here. So you should know that that is 15,000, right? It's between 10,000 and negative 20,000, so it's negative 15,000. That's where my x is 0. Right. So we have the y-intercepts, the x-intercepts, and what kind of profit you will make, or when you will make a profit. And we said we're making a profit as long as we get above 0 and until we come back to 0. All right, let's look at 11.4. 11.4 has you fill out the chart. This is a lot more in depth. This should not take forever, but this is more like our software. Okay, it says the car wash charges $20 for its deluxe wash. At this price, the car wash averages 200 customers per day. Okay, so the number price decreases. Car wash. It says the car wash has determined that for every 25 cents that they decrease the price of the car wash, they will see an increase of 5 customers per day. So the price of the car wash is $20. We'll continue this in a second because I'm going to finish the rest of this on a different type of paper. All right? And we'll come through and explain it.